This is the biology question booklet for Unit 1, and we're on to page 55 now. And question 4. Myasthenia gravis is a disease which causes muscular weakness. So they might give you an example that you haven't heard of, like this. And the body's immune system attacks these synapses or junctions between the neurons and the muscle. And we need two differences and the effect. So one difference you can see there. So we know about synapses release the transmitter and they bind to receptors. Here we've got lots of receptors. Here we've got very few receptors. And so if you've got less receptors, then you've got less chance of the transmitter binding to them and having the effect. So fewer receptors. And the effect is less chance for ACH, so acetylcholine, to bind, and they would open sodium channels and allow the depolarization and action potential, and so less chance of depolarization or action potential. Other difference, you can see there's kind of less surface area, and these tubules kind of go into the muscle and allow the calcium to be released into the muscle to work. And you've got kind of these don't go in as much, which is a problem. So we will mention that less surface area for the postsynaptic membrane. It doesn't go as deep into the muscle, not as deep into the muscle. The effect, well, this will release calcium and have its effect on contraction, so less calcium released, so less contraction eventually. And this links nicely into our part B, which is fewer calcium ions entering muscle fibers, and so this reduces interactions between actin and myosin. So you need to sort of remember, what does calcium do? So less calcium, what effect is it going to have? So the role of calcium is to bind to another protein called troponin, and that changes the shape of the troponin, which causes tropomyosin, one of the kind of fourth protein, to change position, and that allows these cross bridges between actin and myosin to happen. So we break that down. It's very rare they ask about troponin, tropomyosin. So less calcium, cannot bind to troponin. Bind to troponin. And so troponin does not change shape. And why would it change shape? Because that exposes the binding sites on actin, so it causes tropomyosin to change position. So no tropomyosin changing position to expose the myosin binding sites on actin. So overall, even though that's quite complicated, overall you're going to get less of these cross bridges forming. So fewer cross bridges forming, so less contraction. So pretty complicated, that last bit, but the first part A should be okay.